Hi everyone, today is lesson 2. We are working with linear and non-linear relationships with scatter plots. So the data points on a scatter plot can kind of mimic a line or they can mimic something else with curves. So today we're just going to be deciphering between the two.
Lesson 2, linear and non-linear relationships. Your learning target for today is I can identify a linear and non-linear relationship given a scatter plot. Sometimes data can be represented using a linear relationship. Remember, linear, the word line is in it. So linear means that it generally relates to a line. And sometimes the relationship is clearly nonlinear. So sometimes our data points generally form a line and sometimes they don't. So if they don't, it's called nonlinear, and that means that there are curves within your data set. So looking at these options here, it says state the type of relationship, either linear or nonlinear, for each scatter plot below. So if there's any type of curve in your data points, that means it would be nonlinear. So let's take a look at letter A. We have this kind of looks like a mountain, okay? If it's looking like a mountain, that means there's a curve to it. We go up and then we go back down. So that means this is going to be nonlinear. Pause the video and try B and C on your own. Okay, check your work with my work. The tricky one is probably C, because at a quick glance, you might think that that's going in a line, but it kind of has that curve to it. Okay, it's kind of like making that U. It hasn't finished the U, obviously, but it's got that curve to it. All right, so number 2, for each scatter plot shown below, draw a line of best fit, then circle whether the association between X and Y is positive or negative. So this is kind of a review from what we talked about yesterday. Now it says to draw a line of best fit. However, if you're working on the Google Docs, you cannot draw on your Google Docs. So I will draw it for you. So our line of best fit has to go through the majority of the data points, and it has to have about the same amount of data points above the line as it has below the line. So I'm going to draw my, oh, that was horrible. Okay, so I'm going to draw my line as best as I can to get the same amount of data points on top as it is on bottom. Now, if you look real quick, I actually did not do a great job because I only see about 3, 4, 5 data points on the bottom. So let's do that again, shall we? So I'm going to do this. A little bit better. Obviously, I'm human. I cannot be perfect. So our line of best fit is approximately right there. Remember, if we are talking about a line, we're talking about equations of lines. So an equation of a line is y equals mx plus b, where m is the slope and b is the y-intercept. Just reminding you about that because we're going to get to that in tomorrow's lesson. All right, so this right here, reading from left to right, is going up a hill. So it is a positive relationship. Okay, pause the video and give letter B a try. All right, check your work with my work. And let's move on. Number 3, for each scatter plot shown below, determine if you think it is linear or nonlinear. Then draw either a line or curve of best fit. So if it's nonlinear, we can still draw a curve in this case that will best fit the data. So what I want you to do is pause the video and do that on your own. You don't need to draw your curves of best fit, but kind of just think about what it would look like. Okay, check your work with my work. Again, my lines of that, or in this case, curves of best fit are not great just because I'm doing this with a mouse. So just keep that in mind, they're not perfect, but both of these are actually non-linear. Okay, now we have our self-assessment for today. If you have any questions, please let me know and make sure you self-assess.